Okay. There we go. Excuse me. Guess we'll start with the word of prayer. I don't even remember who did it last time.
I have no idea. 1 second.
Oh.
I can say it if you want.
Okay.
Dear Heavenly Father, we thank Thee that we are able to meet together today to discuss pre-calculus and trigonomic identities, and we ask Thee to bless us that we may be able to understand what we are learning and be able to move through this quickly and efficiently, and that we may be able to get the most out of our meeting. And we ask Thee that Thy Spirit may be with us, and we say these things in the name of Jesus Christ. Amen.
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 Okay.
I guess Joe, I cannot pronounce that name for the life of me. Josiah?
Mm-hmm.
I guess he said on here he won't meet tonight. He's got another project.
Oh, okay.
So.
All right.
Okay. So.
Instructions for Google Hangout. Were y'all able to do the algebraic simplification?
I didn't even see what that was. That was probably in resources, huh?
I think it was in the preparation as well.
Yeah. Though, geez, I mean, maybe it was just bad on my part. It would have been nice to see all the trigonomic identities it had the link to, because I think in the preparation work as well, it's got the link for all the sine is this, tangent is this. It would have been helpful to have.
Yeah, it has that.
The only one that I had an issue with that I don't know why, I just can't see why it's like that. It's in the third section of the simplification, and it's number 2.
What is it, x 4x or x times 4 minus x squared over 2 minus x?
Yeah, for that one, is it, I guess I'm just not seeing how they're doing the problem. Like, why is there just, I tried to factor it through and then simplify it that way, and that didn't come out to anything that made sense. And I see what the key is, but I'm just not seeing how the x got with the 2x. Like, I'm just not seeing how the answer came out.
Okay, I mean, I don't know if this will make sense, but we'll have it right here. X 4 minus x squared, and then 2 minus x. So this, it literally just like, it just goes into that like twice.
Could you hold it a bit closer? Sorry.
So you just divide this by this essentially. So you get a 2 minus, and then you keep that x is still there. So it's x, and then 2 minus x, and then you just stick it in there. So it's 2x minus x squared.
Oh, okay. So you can divide the denominator into the parentheses, because I was getting confused because I thought that you couldn't divide it into the parentheses because there was also that X at the beginning. I thought it had to be divided through all of what was in the top part.
I mean, what you're saying kind of makes sense. But like, I don't know. This is what like made kind of sense to me, and then I looked at the answer and it was right, so I went with it. I don't know.
Okay, yeah, I see what it was. So it's that the 2 went into the yeah, I guess I still, so it went in there 2 minus X.
Yeah.
Oh yeah, because doesn't well, I guess the 4 can be divided by the 2 and become a 2, and the X squared with the X in the denominator, that would be 2 minus 1, so that would just give you X, right?
2 minus 1.
Because don't you subtract it whenever they're in the denominator from the numerator, whenever it's an exponent like that? Yeah, because that would give you X parentheses 2 plus X, so that you could simplify it.
Mhm.
I don't know if that's specifically the way of how, but yeah, I was just messing up because, like I said, I thought the X had to be divided by that 2, but I guess it doesn't. So, okay.
Yeah.
I'll just live with that.
Oh, okay. There. Any other questions about the algebraic simplification?
No, I don't think so.
Yeah, other than that, I'm good.
Okay, yeah, same here. As we discussed, should I try questions 3 through 6? Also, the question process used.
Yeah, that page is really nice. I kind of wish I would have stumbled upon it earlier.
That second, the question 3 and then the second problem in there, it stumps like, I'm wondering if there's like a typo or something, because it stumped like 3 of the tutors in the math lab today. Like none of us figured out.
I do know that sometimes there are like a couple, if not, errors on the page. Part of me wonders if she does it on purpose. Because I've noticed there's been on several where there has been a typo or an error or something, and I don't know if it's just making us think, or maybe finger slipped. I don't know.
Just being lazy.
So I posted that in like the questions or whatever, the question discussion board for that. I would like none of us were able to figure that out.
Oh, by the way, I did get back from the TA for our group. I can't remember, it was like 8 quiz or our Google Hangouts or whatnot, but he said he updated it for everyone. I told him everyone's name who's in the group, and he said it was just an error on his end. So he should have updated it with everyone with 100 for, I was like week 8 or week 9. I can't remember, but one of those we got a 0, but it's all good now.
Okay.
I have week 6 as a 0.
week 6.
I think I might have 2.
Yeah,
Not
some of them. I emailed. There were 3 zeros I found, and I submitted 2 of them because it was a Hangout. And in fact, like I can click on the link where I submitted it, and it says I submitted it. The other one was I think one of the quizzes or something. But yeah, he said he looked up those, and I saw that. I haven't checked them all, but I saw one of them was fixed. But he said he had got them taken care of. That it just got overwhelmed with doing stuff. But guess we'll keep tabs on it. If y'all see anything else, we can next time we meet, we can maybe bring those back together and say, hey.
I have a 0 for week 4 group quiz.
4.
I don't know if that goes way far back, so I don't know if we can done about
that. Yeah. So, well, the identity is on here. I'm familiar with this. Okay, so we're focusing on the first couple. Well, these aren't too bad. I mean,
yeah, so that first tangent over secant is like super simple. I haven't tried a lot of these other ones.
Tangent over secant.
I feel like it gives you like a super, super simple example. And then the next question is like, okay, now you know how to do all of the math ever. So here you go.
Right. That's exactly how I feel. Do we each want to take one?
Sure. Of number 3?
Yeah, well, you said number 2 that's the hard one.
Yeah, that's the one that nobody could figure out in the math lab. So we could do like
oh wait, what am I looking at? Hold on. Okay, yeah. Got too many tabs open. I cannot find anything. Okay. Yeah, I don't know if we want to do like one from each section or how you guys just want to work it straight down because we still have the.
Yeah, I like what you said about one from each section. We'll just pick one question. We'll all 3 work on that one and like check our answers.
Okay, make sure we're doing it the right way together.
Yeah, I think that'll work better.
Okay, that sounds good. So for number 3, do y'all want to pick the last one?
Yeah.
That one.
Yeah, we can do that one. Negative x there, huh?
Working on the last one of number 3?
Yeah.
Okay.
Oops.
Uh-oh.
Sorry.
Oh, hello.
It cut. I grabbed the computer because I couldn't see the screen, and when I did, I pushed the button on the side, so it shut down my computer and logged me out.
Oh, whoops.
But I guess it kept the broadcast going because it still says live and everything. So
Yeah.
Hmm.
So good.
It's interesting.
okay. Okay, I'm done.
Yeah, me too.
Yeah, I think I'm good to go.
So was everyone well, I guess, I mean, comparing it to the answer key, was everyone able to get to the 2, what's that, cosecant squared?
Yeah. Yeah, that makes sense.
I got to that, but at the end where okay, so the sine turned into the 1 minus cosine squared x equals sine squared. The 2 over sine squared x, can that just become the cosecant? Like I know that it's the reciprocal identities that 1 over sine is the cosecant, but does it still count if it's squared? Does that have any effect on it at all?
No. Because this is cosecant squared. So sine squared is the same thing as cosecant. There's 1 over sine squared. Cosecant squared.
Oh, okay. I guess that makes sense. As long as they're both staying squared, they're still identities.
Yeah, yeah. You can't go from like sine 1 over sine to cosecant squared or vice versa or whatever.
Okay. That makes sense. Thanks.
Okay. In the resource folder, or use the identities to express the tangent x in the terms of the sine function only. In terms of sine,
so I guess we're turning tangent into sine, but since I guess sine over cosine, we have to turn that into it all sine. Sweet, I got that one.
could you explain what? Because I don't understand. How do they get from a single cosine to something that's equal to cosine squared?
So I used tangent So tangent's equal to sine alpha, cosine alpha, and then ignore this. But in the identities, it has where sine squared x plus cosine. Yeah. So I just did that, and I solved for cosine, which I put sine over, and that's what I did.
Yeah, I forgot it went from. Yeah, I forgot about the square root thing. That yeah, that makes total sense to me now. Yeah.
I forgot the plus or minus, but I did get it for the most part. I forget you have to put a plus or minus in front of a square root.
Yeah. Okay, so I feel like I'm good on that one.
Yeah.
Okay. In the resource folder, you received how to determine if a function was an even, odd, or neither. Use the algebraic technique to determine if the following functions are even, odd, or neither.
Don't remember. What made it even or odd? Oh, was that something to do with the exponents?
Oh.
Might have been.
I can't remember, man. I don't remember there being a neither. I thought it was just even or odd.
Yeah.
That's what one would think, and then math proves you wrong.
Right? Every time.
Well, looks like we need to study that for later. I just checked the resource folder for this week, and it doesn't.
Yeah, I didn't think there was anything for that. I didn't go over that.
I don't know.
Well, maybe we'll look into that, and if we can figure anything out, we can bring it up next meeting. Because I didn't find anything for that either when I was looking over it. But
we don't really have time to go searching for that right now.
Yeah. Okay.
So I'll go on to number 6 then.
Okay.
Multiply or perform the following operations. So that first one is kind of straightforward.
Yeah. Isn't that what we just did on that other one, kind of?
Pretty much.
Yeah, because aren't those just going to multiply? That's just going to multiply together to just like the cosine we just did. So it's going to be 1 minus tangent squared.
Yep.
X. I'm pretty sure. Where's my key? I know. Oh, yeah. Yeah, see, first one's always easy, right?
Oops.
I think the multiplying isn't so bad. I'd probably say I have more of a problem with the
factoring.
Yeah.
I guess just think of like the sign of whatever as like a variable. So like this factoring. Well, no, it doesn't really work for that one. But like that last one, sine squared of beta plus sine beta minus 2. It's like because it's in the a squared plus b equal or plus b plus c or whatever that was.
Oh.
It's like the first term is squared, the second is just and then the third is just a just a number. So that's going to be like a normal polynomial kind of. So, yeah.
I hate it when they're like that. I just can't see it like that ever. But yeah, you're right. I need to pay attention to if it looks like the squared and then the not squared right after it. That makes sense.
There's going to be sine of beta plus 2 and then sine of beta minus 1.
Because yeah, they would have to be different signs in order to get that 2 to be a negative, right?
Yep.
And since the sign in the middle is single, you would have to have the bigger number be.
Yeah,
the bigger number would have to be positive, so that it could subtract. Because you have two sine beta minus 1 sine beta, a regular sine beta. Yeah. Trying to work backwards in my head.
Yeah.
Okay. Yeah, but so then you'd have the 2 would be plus and 1 would be negative.
And then that middle, or that other factoring one, is also kind of straightforward. You just have to separate them out, and like one is just secant x minus cotangent of x, and then the other is secant x plus the cotangent of x.
Okay, yeah, that one's fine.
Oh man.
Well, for 7's verifying identities, which, I mean, I think it's cool. I like it. I like having one thing equaling your whole end product. But does anyone have any other questions about identities, or do y'all want to go to the other part of it?
Let's go to the other part.
Yeah.
See. See how much we can do. Okay. Checked it, verified. And then go to the extension problems. As you learned from the preparation assignment, it only takes one case to prove something is false. Show that the following equation is not an identity and discuss why.
Because they're signs of two different things?
Yeah, like one's 2 signs and the other is only 1 sign, but it's multiplied 2 by x.
Okay.
I mean, I guess I don't know how you'd show specifically. I'm going to take a peek at the key. Yeah, because I mean, the 2 is in 2 different. It's. Well, I mean, I guess you could solve it like the sine of 2. Let me see. Like, let's say 5. Sine of 2 times 5 is different from 2 sine of 5. Wait. No, it's not. But yes, it is. Yes, it is. Never mind. Yeah, I mean, they're 2 different values. Even if you plug in the same x, you're getting two completely different values, so those can't equal each other. But
okay, makes sense. Following problems guide you to the answer to the question finding equivalent, blah, blah, blah. Find an equivalent algebraic expression for Massacre.
okay. So don't do the way the book has it, is what I'm getting. So is it wanting us to rewrite that expression as something different? Or is it walking us through the steps of how we do that?
What are you looking for?
An equivalent expression.
Oh, begin by drawing.
So, yeah, is it wanting us to do normal tangent and I guess I don't get what the equivalent algebraic expression is. Does it want us to rewrite it in terms of like tangent or something? I don't know.
I have no idea. That's interesting.
Yeah, and it's like for the question given, what are you looking for? I don't know, another expression. I'm not sure what it's wanting us to do, I guess. In this book, you'll find a different process. We introduce you how to calculus. Oh, okay, so maybe it is walking us through it. Given that x is a side length, the output of tangent is not the side length.
It's an angle because the inverse function, given that an x is a side length and the input.
Oh yeah, you use the inverse to find angles, don't you? Right?
Yeah. So that's
okay. So draw a right triangle. Check. So sine is the side length. Oh wait, never mind. Don't listen to me. That's x. So the angle across from x is the tan inverse of tangent? Are those corresponding?
Oh.
Mm.
So it's like find the third side. We were given two sides. Because one side is x. Let me look at the key and try to work backwards. Oh, I see what they're doing. So in the key, it's doing the identities of like is that the a squared plus b squared equals c squared? Maybe?
Maybe.
Or
The Pythagorean theorem.
yeah, well, where's that one I just looked at the answer key and I'm like, where's that one coming from? Why is it not also squared?
Mm.
Yeah, I guess I'm not understanding I guess I'm not seeing how they're getting the other lengths. I see how they're factoring it out, but they've got x squared plus 1 equals unknown squared, which they turn into c. But I thought they were doing the Pythagorean theorem. But why would there not be a why wouldn't it be like x squared plus b squared equals unknown squared? Or I don't understand where that one came from.
I don't know.
Yeah.
Okay.
Oh, wait a minute.
I have no idea.
Yeah, I don't know.
Yeah, I just went through. I was looking through the Pythagorean identities, because I know there's a 1 in those. So I was thinking maybe they use those identities because it makes sense with the triangle stuff, but I'm just not getting why they're doing what. That might be one to talk to the TA about, or something, because I don't really. I have no clue how to get through there.
we could go on to number 3 then.
Okay. Got about 10 more minutes or so.
Yeah.
I
So,
get back to y'all. I don't know why I'm so tired. Y'all want to work on the second one? The first one just looks like it would just factor out to the same thing.
yeah, for the most part, you can't factor. The factor is sine squared x minus cosine squared x, and then sine squared x plus cosine squared x. And then you can factor that first part, the sine squared x minus cosine squared x again, but you can't factor that first one. It'll be sine squared x plus cosine squared x, and then the other one is factored out.
Okay. You just got to watch signs real careful on that one.
Yeah.
But that makes sense.
Yeah, definitely. This next one, though.
Okay. Well, I got it half right.
Hmm.
Yeah, I got the tangent x. I got the cosine -3, but I didn't get the cosine +1.
What did you get?
I got cosine minus 2, but I guess that doesn't multiply out the same thing either.
Yeah, I don't know where this 1 is. Oh, wait a minute. It's because...
Is it an identity? An identity?
No, let me think about this. So you multiply the... Well, I only can like tell by... No, never mind. Yeah, you can do it. Okay, so here, let me write it out. So what it is, I think, is it's okay, here we go. So we have cosine squared of alpha tangent alpha minus 2 cosine blah blah blah. So you take out a tangent.
Okay.
You're left with cosine squared of alpha minus 2 cosine of alpha minus 3. And then if you factor it out, so you get this times this gets you the cosine squared of the alpha. And then you have 1 positive cosine of alpha, and then you have 3 negative cosines of alpha. And add them together, you get negative 2 cosine of alpha.
Oh, okay. Ugh.
And then the 3 is the 3 and the 1 is just negative 3.
Okay, I got to the step right before, and I wasn't factoring. I hate factoring like that. Well, that makes sense. Thank you. I was trying to figure out where it came from, but I see that. Okay, well, it's about to be 8 o'clock. I gotta hop off at 8.
Okay.
Oh.
Might as well just, I guess, end there.
I'll shoot the TA. I mean, I don't know if y'all go to the math lab or also email, but I might email about that other one because I really didn't understand it at all. And I guess we can come back together and figure out maybe how it's supposed to be done, so that'll help us.
Yeah.
Yeah, I'll probably do that.
Okay, let me turn the broadcast off.